Hello everyone, welcome to what is now the 8th week of online chemistry lessons. If you just bear with me, I will share my screen with you. Here we go. So make sure that you, as always, have a piece of paper or a notebook and a pen or a pencil with you. So if you don't have that, then just run and grab that now. Hope you're all well. And the learning question for today is, what is chromatography? So you've probably all carried out chromatography at some point in school, either in the last couple of years or at Key Stage 3. So we're going to just be having a little revise of it and covering it and looking at the sorts of GCSE questions you might find on it. But firstly, there is a tiny bit of revision on what we did of the properties of metals, so the structure and the properties of metals. So if you remember, metals have got high melting points and they can conduct electricity when they're solid or liquid. What I'd like you to do is look at those properties and write out each property, so high melting point and conduct electricity, and match it up to its explanation. So which part of its structure, so which part of the structure of metals explains the property high melting point, and which of these explanations of the structure explains conducts electricity, explains why metals can conduct electricity. So if you can just pause the video and have a go at doing that now for me, please. Well done. So hopefully you all remembered high melting point is because bonds are strong. So the bonds between the atoms of metals are very strong. So that's why it has a very high melting point. And it can conduct electricity because there are ions that are free to move around. If you remember, in a metal, the structure had positive ions in like a lattice structure, and it had electrons that were what we call delocalized, so they could move around. So either you could say electrons free to move around to carry a charge, or you could say, as it says here, ions free to move. Okay, so give yourself a tick if you got that right. If you want to make a little note of that, then pause the video and do that now. So moving on then to look at chromatography. So paper chromatography is used to separate mixtures of soluble substances. Okay, now the substances need to be soluble because they need to be able to dissolve in water and move up the paper with the water. So now, these are often coloured substances like food colouring or ink or dye, or we can use plant pigments like chlorophyll. So I've got here a little example of a use of chromatography. So chromatography can sometimes be used in crime scenes. Say if there's been a note written in pen, you could try and find out the mixture of soluble substances inside that pen so that you could match it or try and find out which pen it was written in. So another few uses of where chromatography is used in everyday life. It's used to check that our food and medicine doesn't contain dangerous impurities. So some food colourings are actually banned. And sometimes like the Food Standards Agency might test a product that's got food colouring in it to test that it doesn't have any of these banned substances. Testing our water to check what's in our water to make sure it's not polluted, and police and forensic scientists to identify substances that they find at a crime scene. So what I would like you to do, please, is write down the letters A to F in your margin. And what we're going to do is we're going to watch a quick video with an explanation of chromatography. And then what we're going to do is we're going to try and label these parts of chromatography equipment. If you would like to draw out a little diagram for yourself of this chromatography equipment, then you are free to do that. But I realised that I thought to myself when I was designing this lesson, I've asked you a couple of times to draw out equipment, so I thought I'd be a little bit lenient this week and just say that you just, if you write A to F, and then you can just write a note next to it what they are. So the words, the labels for these are here, so I've written them all in red here. And what we're going to do is we're going to watch the video and then have a look back at the equipment to see if we can label it. Here we go. So I will move myself down there so that you can see whose face is talking. Okay, so we'll watch this video and then we'll go back to look at the equipment on the slide.
Paper chromatography allows us to separate substances based on their different solubilities. So let's look at an example. Imagine I have a collection of coloured pens such as these. I want to know which pens contain only one colour and which pens contain a mixture of colours. We take a piece of special paper called chromatography paper and we draw a pencil line near the bottom like this.
Okay, so you take a strip of chromatography paper and it's kind of like filter paper. It's a special paper. It's a special paper because it's absorbent, so the water can move through it. And you draw this pencil line. Now, I think he goes on to explain why it's really important that you draw the line in pencil in a moment. So I'll wait for him to explain that part to you.
Next, we put a dot of our first colour onto the pencil line, and next to that, we put a dot of our second colour. We can do this for several colours, as long as there's enough space on the paper. We now place the bottom of the paper into a solvent. Remember that a solvent is a liquid that will dissolve substances, and there are lots of different solvents.
So usually if you've done this in school, you would just use water as your solvent, but there are different solvents that you can use. You can use ethanol and some other solvents.
Now here's the really important part. The solvent now makes its way up the paper and it dissolves the ink in the two coloured dots, and these are now carried up the paper as well. Now here are a couple of facts that you need to learn. We call the paper the stationary phase because that does not move. And we call the solvent the mobile phase, and that's because the solvent moves. So after a while, the paper could look like this. As you can see, the red colours formed a single spot here. Because there's only one spot, we know that red is a single pure colour. However, you can see that colour B has now separated into two different spots. And that tells us that colour B was actually a mixture of two different colours.
Okay, so you can see he had colour A and colour B here. Because there's only one spot, like he said, it just contains the one type of dye or pigment or ink. Whereas here, colour B separated out into these two spots. So it's actually a mixture of these two colours mixed together.
So here's another key fact. A pure compound will produce a single spot in all solvents, whereas the compounds in a mixture may separate into different spots depending on the solvent. I've shown you that with these two diagrams. These show the experiment again, but this time repeated with a different solvent. You can see that the red colour still produces a single spot, even if we change the solvent. The position of the spot may change, but it's still a single spot. Paper chromatography works because different substances have got different solubilities. A more soluble substance travels further up the paper than a substance which is less soluble. One question which is often asked in exams is, why do we draw a starting line in pencil?
When he says often asked, I promise you, any question in a GCSE paper that is about chromatography, I haven't ever seen one that doesn't have this part of the question in it.
Well, that's because if we drew the line in pen, the pen ink would move at the paper with the solvent.
Okay, so if you did draw the line, it's really important to draw that line in pencil, because if you drew it in pen, the pen could dissolve into the solvent and move up the paper, and it would just completely spoil your results. Okay, so that's really, really important to remember. A question that's asked so often, why you draw the line in pencil. Okay, so back to, oh, hang on. So back to our slideshow. So remember, I said that you could draw out that chromatography equipment if you wanted to. So down here is the solvent. This is the glass beaker. You've got the chromatography paper here, the pencil line here, and you've got the different inks here. Okay, but you don't have to draw it out. If you've just written A to F, then here we are. So the solvent front is the name we give to how high up the paper that solvent has moved. So if you're using water, you'd be able to see how far up just the water on its own went. And at the very top, that's what we call the solvent front. All right. The separated dyes are here. So they're the different colours that you can see on the chromatography paper after you've waited a while. This here is the filter paper or the chromatography paper. The ink spots are down here in the pencil line, and the solvent is here at the bottom. So it's what the chromatography paper or the filter paper is just dipped into. Okay, well done. So now we're going to have a little pause and just check our understanding with a quick question here. So looking here at these inks, 3 of them have only got one colour in them. Which 3 are they? So which 3 of those inks? You've got 6 inks there. They would have started with 6 ink spots here at the bottom on this pencil line. Which 3 have only got one ink colour in them? Okay, so write down your answer, write down your guess. Well done. Okay, so it's A, because A only formed one spot, and B, because here on this B line you can see there's just one spot, and E, you can see that E has got one spot here. Okay, you may be asking why F is still here at the bottom. So what we know about F, because it hasn't moved at all, that it is insoluble. So whatever the mixture of inks are in that coloured pen F, it's insoluble. So you can't study it using chromatography. Okay, so a series of sentences here. So there's just 3 short sentences that I would like you to copy out and see if you can fill in the blanks. So if you pause the video, write out those 3 sentences and see if you can fill in the blank words I've covered up. Fab. Well done. So if you managed to get them, then you can give yourself a big tick. If you didn't, then hope you've left a little blank space and you can write them in now. So chromatography separates substances in a mixture. It works if all the substances in the mixture are soluble. And the picture made by chromatography is called a chromatogram. Okay, and I'll just move this box very quickly because this is quite a nice diagram of the chromatography equipment that we use in a lab. What we do, so this is the glass beaker, and if you've done chromatography in a lab before, we put a splint here across the glass beaker and we sort of paper clip the chromatography paper on it just to keep it still. There we go. Okay, now I have got an exam question for you. So this is a real practice exam question. So I'd like you to, I'm not going to read it out to you this time. If you can read through it and try and answer it, and then what we'll do is we'll go through it together in a moment. So pause the video, read through the question, have a look at the diagram for yourself, give yourself a couple of minutes to answer it, and then we will go through it together. All right. Well done, fab. So hopefully you've had a chance to have a go at those questions. So Gary drew the baseline in pencil. Why should he not draw it in ink? So pencil doesn't dissolve, and so it doesn't affect the results. Or you could have said a pen or ink might dissolve in the solvent or in the water and affect the results. So you could have said it the other way around. Okay, but that's why. Number 2, which food colouring contained the banned food dye? So we can see here is the banned food dye, and this spot here shows the substance that it contains. Now if we look along the chromatography paper, the only dye with a compound in it that is the same as that substance, has moved the same distance, is this one here from the yellow. So we know that this yellow food colouring contains that banned substance, because that banned compound has moved up that far in the banned food dye sample, and so therefore we know that that's in the yellow one as well, because we can see there is a compound there that's moved the exact same distance. Which food colouring contains the most dyes? So that is the brown. We know that because it's separated out into the most different compounds, so it contains the most different dyes. And which food colouring did not dissolve in water? So that's the red. So all of the compounds in that red food colouring are insoluble. So it is impossible to look at what makes up that mixture. Okay, so give yourself a mark then out of 4. And if you need to correct any answers, then just pause and do that now. Well done. We're nearly at the end, guys, so stick with me. Okay, so the last question is a 6-mark question, and you don't have to do this now. You are welcome to come back to it or write it down and then have a go at it later. It could be like revision. You know, sometimes if you come back to something the next day, it's a really nice way to revise it. But please do have a go at this question. And please, if you can, try and submit it on Shoddy, because then myself or another science teacher can mark it for you. So a student wants to investigate which pigments are used to make ink. Describe how she could use paper chromatography to identify how many pigments are in the ink. Okay, so try and include as many points as you can. All right. Fab. I will leave that with you, and have a fantastic week. And I will see you next week. If you are year 10 and you are in school at all, we are all very much looking forward to seeing you, and please do wave hello. Okay, well done, guys. See you next week.